Yes, hello guys, welcome on Upedia platform. I hope you all are fine, preparing well. I am Vishal Sharma, and guys, as you all know, here at Upedia we launched NPTEL assignment module. And you know guys, this is very extensive module for your GATE preparation, for your bar preparation and any other competitive exam preparation. You know guys, if you want to improve, enhance your fundamental skills, okay, so NPTEL assignments are must actually to solve. Okay, so you can practice more and more questions through these NPTEL assignments. You know, like last year for GATE 2022 we launched this module on YouTube on free of cost basis, and lots of assignments, NPTEL assignments we have covered in those live classes. Okay, now we launched this module with a very minimum cost, and each and every one of you can go for these kind of modules. And guys, other than those NPTEL classes, we are providing you the doubt classes, we are providing you the new question classes also on Zoom platform. Okay, so there is no not like that we are only launched NPTEL assignment module. Other than NPTEL assignment, we have clubbed it with the all textbook question also. So we are going to pick all important question from the textbook, and even some of the NPTEL assignment also we are going to find out some questions in NPTEL assignment we can find out in very good standard foreign author textbooks. So we are going to pick directly some questions from those foreign author textbooks also, and NPTEL also, which is a very good relevant resource for any engineer. Okay, so till we have launched till now we have launched this module for mechanical, civil and other branches also. So you can go to our website and you can think of purchasing this module, because this is very important for you for your GATE and other competitive exam preparation. So guys, let's start our today's discussion. In today's session we are going to discuss one question. So I picked one question from the thermodynamics. The question is this in front of you. You can read or you can note it down. Guys, it will be good for you if you will note it down, this question, on your textbook, and then if you will solve, that will be also good. Okay, so you can apply your mind before observing the solution. You can try your own. Okay, if you are getting the solution, it's very good. Otherwise you can watch the solution. Okay, so guys, the question is I picked two questions, common data question 1 and 2. So there is a reversible steady state flow device. So this device is shown to us reversible. This device is reversible steady state, which is getting some air is entering at 1 kg per second. Okay, at this temperature, this pressure it is leaving, the same air is leaving at this particular pressure, this particular temperature. There are heat transfers also, like the all heat transfers are given to you, CPCV values are given to you. So what he is asking you? He is asking you in first part the heat transfer at 500 Kelvin. What will be the heat transfer in this case? Okay, guys, typically when we solve this kind of question, I think most of you are aware about those questions where there is a heat transfer. Okay, from one source we are getting heat, from another source we are getting heat, and to another source we are another sink we are rejecting heat. So these kind of questions we are much aware. But in this case, other than heat transfer, the mass is also entering. So it is not like that only heat is entering. So if you want to find out this heat transfer, you cannot apply here. आप यहाँ पे ये apply नहीं कर सकते. You cannot apply here this cyclic integration. Let me write it here. You will not be able to apply here this cyclic integration of dq by t equal to 0. With this you are not going to get the answer, although this device is reversible, okay, and this is in steady state, but with this you are not going to get the answer, because if you apply with this, like q1 by t1, q2 by t2, both are positive heat addition, minus like q1 by t1, q3 by T3, both are positive, because this and this both are the heat addition, minus Q2 by T2, which is 350 Kelvin. With that you are not going to get the answer. Why? Because other than heat transfer, mass is also entering, mass is leaving. So then how to solve? Okay, the question arises how to solve. Okay, and other than this, there are two parts actually. In this question there are two parts. This is part 1 and this is part 2. He is asking you the rate of work produced also. So rate of heat transfer, rate of work produced. Okay, so both these two things you need to find out, and two very important concepts we are going to discuss, guys, through this question. Okay, so let me first discuss with you some of the very general thing actually, like what do you mean by this reversible and steady state? Okay, reversible से और steady state से क्या मतलब है? So guys, you all know reversible means a process. Let me write it here. A process is said to be a reversible process a process is said to be a reversible process if it can be reversed, if it can be reversed, if it can be reversed in its direction, without affecting the universe. Okay, without affecting the universe. Universe means system and surrounding. System plus surrounding. So merely reversing the direction of a process doesn't mean the process is reversible. Like suppose if I will take a kind of, suppose this is a flat surface, okay, and suppose on that flat surface if I will take a block, okay, so this is a block which is placed over this, okay, so this is the position of the block, this is position 1 for example, and suppose you applied some force, okay, and you moved this block from this position to this position. आपने इस block को क्या कर दिया, move कर दिया. So this is state 1, this is state 2. Okay, so when we are moving this block from 1 to 2, obviously there is a friction between the two surfaces. Friction cannot be 0, so there is friction, and due to friction the heat is going in what? The heat is going into the surrounding. For example, heat कहाँ जा रही है? Heat is lost into the surrounding. Okay, it is negative actually, minus Q surrounding. Why? Because heat is entering into the surrounding. You are not taking heat from the surrounding, heat is entering into the surrounding. Okay, now actually moving 1 to 2 you are not going to get any kind of work, okay, but suppose in this case you can take example something like this. At least you can think of getting some work output. So you can draw a block something like this also. आप block को ऐसे भी draw कर सकते हो. You can take example something like this. So this is position 1, you are moving it from 1 to 2. आपने इसको 1 से 2 क्या कर दिया, move कर दिया. You moved it from 1 to 2, and suppose when you are moving it from 1 to 2 you are getting some work. आपको क्या मिल रहा है, कुछ वर्क मिल रहा है. फॉर एग्जाम्पल बिकॉज यू आर डिक्रीजिंग इट्स पोटेंशियल एनर्जी, आप इसका पोटेंशियल एनर्जी क्या कर रहे हैं, डिक्रीज कर रहे हैं. सो सपोज यू आर गोइंग टू गेट द पॉजिटिव वर्क, ओके, यू आर गेटिंग पॉजिटिव वर्क बट द हीट ट्रांसफर इज नेगेटिव. 1 to 2, W1 to 2 and Q1 to 2. ओके, नाउ सपोज यू वांट टू रिवर्स द प्रोसेस. आप प्रोसेस को क्या करना चाह रहे हो, रिवर्स करना चाह रहे हो, मींस 2 to 1. ओके, so the work which you got, for example, the same work you supplied to move this block from 2 to 1. For example, in this case, obviously again you need to supply some work also from moving 1 to 2 and 2 to 1. Okay, displacing. In this case, suppose 1 to 2 we got some positive work. Now moving 2 to 1, we are supplying some work. Suppose negative W1 to 2, W2 to 1. Okay, this is W2 to 1 negative, for example. Okay. चलिए, so this is negative 2 to 1, but when you are moving it 2 to 1, again due to friction the heat is going to generate, and where that heat will go, again the heat is going into the surrounding. So Q1 to 2, that is negative, heat is going into the surrounding. Q2 to 1, again heat is going to the surrounding. So there is net effect is remaining on the surrounding. Net effect is there. Net effect is remaining on the system and surrounding. मान लीजिए सिस्टम को आपने रिस्टोर कर भी दिया. फॉर एग्जाम्पल यू रिस्टोर द सिस्टम टू द सेम इनिशियल कंडीशन. इट मीन्स देयर इज नो इफेक्ट ऑन द इफेक्ट रिमेनिंग ऑन द सिस्टम, बट इट डजंट मीन द प्रोसेस इज रिवर्सिबल. ए प्रोसेस इज नोन एज रिवर्सिबल इफ द बोथ सिस्टम एंड सराउंडिंग बिकम्स अनइफेक्टेड. ओके, in that reversal of the process, net effect is there on surrounding. It means the process is irreversible. Process क्या हो जाएगा बच्चों? Process is irreversible. Okay, a process is known as reversible only if you can reverse in its direction without affecting the universe, means without affecting the properties of universe. देखो affecting the universe का मतलब क्या है? Properties of universe. Properties of universe. यूनिवर्स का प्रॉपर्टीज अनअफेक्टेड रहना चाहिए. देयर विल बी नो चेंज इन द प्रॉपर्टीज ऑफ यूनिवर्स. ओके, प्रॉपर्टीज ऑफ यूनिवर्स. But if due to some process the properties of the universe, like it may be system, it may be surrounding, if properties of the universe are changing, it means the process is irreversible. In actual case, real life, there is no such reversible process possible. All processes are irreversible only. But you can give some kind of example, like suppose if you will take a very slow, okay, very slow, or what you can say quasi-static isothermal compression, okay, of a gas or expansion of a gas. Isothermal, very slow isothermal compression or very slow isothermal expansion of a gas, that process you can equate it with the kind of reversible process. Similarly, suppose you are compressing a spring, you are expanding the spring. So compression and expansion of a spring without any kind of hysteresis loss, that is also a kind of reversible process. But in real cases, there may be some kind of, there can some kind of hysteresis losses are going to occur. What is hysteresis loss? It is kind of, loss in mechanical energy. Okay, when you are cyclic loading, or what you can say cyclic compression or extension of the spring when you are carrying out, so due to that cycling compression and expansion of the spring, some kind of loss in mechanical energy occurs. That loss in mechanical energy due to cyclic compression and expansion of the spring, that is known as hysteresis loss. So in real case, that may be there. Okay, so what you need to know, what you need to think, in a reversible process, there is no effect is going to remain. There is no such kind of loss in energy is going to take place. But in a irreversible process, there must be some loss in energy. Exergy destruction is going to take place. There must be some irreversibility, and there must be some entropy generation in all real processes. Okay, so I think you got the idea. What is a reversible process? A process is said to be reversible if you can reverse it without affecting the universe, without affecting the properties of the universe. It means the entropy generation is zero. It means irreversibility, which is T naught delta S generation, that is zero. Okay, in a reversible process. किसमें? Reversible में. Okay, reversible में ये क्या होगा? Zero होगा. Entropy generation zero, irreversibility will be zero. And what is irreversibility, guys? What is irreversibility? Irreversibility is nothing but loss in available energy. Okay, irreversibility को ही हम क्या बोलते हैं? Loss in available energy or exergy destruction. Exergy destruction. Okay, so you can mention it as irreversibility, you can mention it as loss in available energy, or you can mention it as exergy destruction. So all will be zero in case of reversible process. But in case of irreversible or real processes, reversible processes are not real processes, guys. These are non-real or hypothetical, or what you can say ideal processes. So all reversible processes are ideal, non-real processes. But these are most efficient. ये क्या होते हैं? Most efficient. ये क्या होते हैं बच्चों? Most efficient. If how you can say these are most efficient? Because no loss in energy, no loss of energy. कोई भी एनर्जी का लॉस नहीं होता बच्चों. रिवर्सिबल प्रोसेस में कोई भी एनर्जी का लॉस नहीं होता. And if there is no loss in energy, it means the process is most efficient. That's why reversible processes are the most efficient. I hope you got some basic understanding about this reversible process. Okay, चलिए next हम move करते हैं बच्चों. Steady state. दो चीजें हमें डिस्कशन करनी थी, रिवर्सिबल, स्टेडी स्टेट. स्टेडी स्टेट का मतलब क्या होता है? स्टेडी स्टेट मीन्स a system is said to be in steady state. Okay, a system is said to be in steady state if no accumulation of the energy is taking place in the control volume. Okay, in the control volume, no accumulation of the energy is taking place in the control volume, then that state of the system, that is known as steady state. Okay, no accumulation of the energy is taking place means ये कब होगा बच्चों? When whatever energy is entering, that is equal to energy leaving. It means is that change in energy of the control volume, rate of change of energy of the control volume, that is zero. The energy of the control volume, the energy of your system is not changing with time. So if energy is not changing with time, then del E by del T of the control volume, that will be zero. Okay, so what is the general equation, guys? The general equation is rate of energy in minus rate of energy out. So that is equal to del E by del T of the control volume. So this is general equation for any steady or unsteady system. For unsteady, this term is going to exist, but for steady this term will be 0. And if this term is 0, then you can write here the rate of energy in that is equal to rate of energy out. This is very important equation guys for steady flow. Steady flow, and this equation we are going to apply to this particular question. Okay, energy in equal to energy out, rate of energy in equal to rate of energy out. There is no accumulation of the energy is taking place in the control volume. Okay, one more thing you can write it here. Other than this, the properties of the control volume, properties, because if there is no accumulation of energy is taking place in the control volume, it means the properties of the control volume are not going to change with time. Properties are invariable with time. Properties of the system are not going to change with time, not changing with time, not changing with time. Okay, so what you can say, suppose any property x is not a function of time. Okay, ये क्या है आपका any property, but in case of unsteady the property becomes function of time. Unsteady में property क्या हो जाएंगी, they becomes function of the time, because the sum of the accumulation of the energy is taking place, is going to takes place in case of unsteady system. ओके तो स्टडी में एनर्जी इन इक्वल टू एनर्जी आउट, और यहां पे आप एक चीज और लिख सकते हो, मास इन इक्वल टू मास आउट, mass in equal to mass out. Further there is no accumulation of mass also taking place. Mass का भी कोई accumulation नहीं होगा, no accumulation of mass as well as no accumulation of energy. Okay, no accumulation of mass as well as no accumulation of energy in case of steady state. Okay, so I think you got the idea, some basic idea about steady state and reversible process. Okay, now let us quickly move to our question. Okay, अभी हम move करते हैं अपने question पे बच्चों. So this is the question. Okay, you know, like I just discuss these things, basic things, so that you will get some basic idea. Okay, I hope you know also all those kind of things. So now this is a question guys in front of us. 1 kg air is entering, so this is 1 kg air, 1 kg per second, this is the mass of the air entering, and obviously if this is in steady state, so whatever mass is entering, the same mass is leaving, because there is no accumulation of the mass. So he has actually not given you the exit mass, but we know that. Why? Because it is in steady state. Steady state में कोई भी mass का accumulation नहीं होगा. The process is reversible. ये process क्या है? Reversible. So what idea we are going to get? This we cannot write, because other than this heat, there is mass interaction is also taking place. But what we can use it here? हम यहाँ पे use क्या कर सकते हैं बच्चों? What we can use it here? We can use entropy generation will be 0, because this is a reversible process. So if this is reversible, entropy generation, okay, this is reversible, entropy generation will be 0. Entropy generation will be 0. Okay, this is in steady state. Steady state में भी है. It means what? It means the change in entropy of the control volume, del S by del T of the control volume, that is also 0. Properties, entropy is also a property guys, you know, although it is what? It is a kind of extensive property, so it depends on the size or mass of the system, but entropy is also not going to change. In steady state, the change in entropy of the control volume is also 0. There is no entropy generation. Why? Because the process is reversible, no entropy generation. It is in steady state, so change in entropy of the control volume is 0. So from this, we will get the very important relationship. What is that? We will get entropy in, rate of entropy in minus rate of entropy out plus entropy generation, rate of entropy generation. I am writing all these terms in terms of rate actually. Rate की term में लिख रहा हूँ. Why? Because he has given you all heats in watts. इसने जितना भी heat आपको दिया है, he has given you these heat transfer in watts actually. Okay, और आंसर भी किस में आ रहा है? Watts. All answers are given in watts. That's why I am writing here entropy rate, and energy also, the energy balance also I am going to write it in terms of the watt. Okay, so rate of entropy in, rate of entropy out plus entropy generation equal to change in entropy of the control volume, rate of change of entropy of the control volume. Okay, now you know in steady state this is 0 and this is also 0. So whatever entropy is entering, that is equal to entropy leaving. Okay, entropy leaving. Specific also you can write, whatever entropy is entering, that is equal to entropy leaving. Got that idea guys? Whatever entropy is entering, that is equal to entropy leaving. So this is first equation which we got. पहला इक्वेशन अपने पास आ गया है. Okay, got the idea guys? But other than heat, the mass is also bringing entropy inside the system. Okay, like suppose if there is only, listen very carefully, if there is no mass transfer, then whatever entropy is entering, how much entropy heat is going to bring? The heat is going to bring Q by T positive minus Q by T, because that is going. So entropy of the system is going to decrease, heat is going out. Okay, so Q1 by T1, Q3 by T3 plus minus Q2 by T2, that will be 0 in case of what? If there is no mass transfer. Okay, because mass is not entering, so mass is not going to bring any kind of entropy. Suppose that is a kind of closed system. If you are having a closed system, only heat transfer, no mass transfer, then yes, you can write this particular equation which I have mentioned earlier, cyclic integration dq by t equal to 0, because the process is reversible. But in general, the cyclic integration dq by t, you know that how we write? Okay, closest inequality. Okay, तो वहाँ पे अपने को क्या समझना पड़ेगा? Closest inequality, that can be 0 or less than 0. Okay, that can be negative also. For reversible it will be 0, for irreversible that will be less than 0. Okay, closest inequality. And ds is greater than equal to dq by t. For reversible, ds equal to dq by t. That's why I am writing the heat transfer, the entropy change with that entropy, how much heat is bringing, that is q by t. Okay, so in case of reversible process. But here the mass is also entering, so you need to mention the entropy, whatever entropy this mass is bringing, whatever entropy that mass is leaving out. So suppose this point is 1, this point is 2, so mass is same, mass flow rate is this, so how much entropy in is taking place with mass, that is m dot s1, how much entropy it is taking out, that is m dot s2. So this will be positive because this mass is entering, this is going out, so that is m minus m dot what you can say s2, or you can write it as this side, आप इसको इस side भी लिख सकते हो, because I have mentioned entropy in equal to entropy out. Okay, so this is the first important equation which we are having. Other than this guys, we are having one more equation. What is that? You know, system is in steady state, so whatever energy is entering, that is equal to energy going out. No accumulation of the energy. Energy in equal to energy out. Okay, so but what is entering guys? Is there is only heat is entering? Heat is entering, heat or work interaction is taking place? No. Other than heat and work interaction, the mass interaction is also taking place, and masses can also bring some kind of entropy. But here if you will check, neglecting the kinetic and potential energy changes, काइनेटिक एनर्जी और पोटेंशियल एनर्जी चेंजेस को अगर हम नेग्लेक्ट कर दें, नेग्लेक्टिंग काइनेटिक एनर्जी एंड पोटेंशियल एनर्जी चेंजेस, so mass can bring some kind of kinetic energy, potential energy, and what? The enthalpy. And you can write it here internal energy also, or entry flow work, exit flow work. But you know how we write steady flow energy equation? H1 plus C1 square by 2 plus ZZ1 plus you know Q, that is equal to H2 plus V2, yeah, C2 square by 2 plus ZZ2 plus work. But if there is no change in kinetic and potential energy, then we can simply write it as H1 plus Q, that is equal to H2 plus W, something like that. Okay, something like this. H1 plus Q, that is equal to H2 plus W, WCV, small WCV. Okay, that will be small WCV in case of what? Neglecting the kinetic and potential energy changes. Okay, neglecting kinetic and potential energy changes. Are you getting guys? So similar kind of energy equation we can write it here also. This is capital E, energy in. So whatever, how much enthalpy is bringing, suppose this is H1, capital H1, because mass is entering, and mass is entering with some enthalpy H1, because it is entering at a point 1. So this is H1 plus, how much Q is entering guys? Q is entering at 2.1 and 3. So I am writing it as Q1 plus Q3, Q1 plus Q3, yes or no? H1 plus Q1 plus Q3. How much energy is going out guys? Energy going out is H2 plus Q2 plus W, yes or no? So this is the specific term, in specific term this is in terms of what? Total energy. Okay, neglecting kinetic and potential energy changes. Okay, now how you can write this H1? This you can write it as M1 dot into Cp T1, considering the ideal gas, air is an ideal gas, plus Q1 dot plus Q3 dot equal to M. This mass is same, so you can also this also you can write it as M1 dot. M1 or M2 you can write it as M2 also, but otherwise both are same. Okay, दोनों क्या है बराबर है, both are same. So this is M2 dot Cp T2 plus Q2 dot plus W. Okay, now let us put all the equations values. So M1 dot is what? This is 1. इसको मैं इधर ले आता हूं. So this is 1 into Cp is 1.004. I think these values are given to you. You can check it here. 1.004 kilojoule per kg Kelvin. Okay. T2, the change in temperature is T1 minus T2. So how much is the entry temperature? The entry temperature is this 400. Okay. The exit temperature is 800. Okay. So 400 minus 800. Okay. Plus. How much is Q is entering? How much is Q is entering, guys? Let's check it here. Q1, the heat transfer takes place from heat transfer of 800 kilowatt is taking place from 1000 reservoir, 1000 Kelvin reservoir. Means Q1 equal to 800 kilowatt. This is 800 kilowatt. Okay, 100 kilowatt is rejected to this, so this is 100 kilowatt. Okay, this is 100 kilowatt. And this one we don't know, Q3 we don't know. Okay, so this we don't know, this we want to find out actually. ये तो अपने को नहीं पता. And this one is what? This one is 100 kilowatt, 100 kilowatt. And this is positive, this is negative. Okay, Q3 we don't know. ठीक है, चलिए. So Q1 is 800. Okay, Q3 we don't know. So this term already we have mentioned it here. So now no need to write it here minus. Minus यहाँ लिखना नहीं है बच्चों. Why? Because already we are writing energy in and energy out. Okay, energy in equal to energy out. So अगर आपको इसको इधर लेके आना है, then obviously that will become negative. Automatically वो क्या हो जाएगा आपका? Negative हो जाएगा. Okay, energy in will be positive, energy out will be negative. So इस side लिखोगे if you are writing it here, this side, you know, when we are writing it here, this side, then obviously heat added to the system is considered as positive, rejected by the system is considered as negative. Addition positive, rejection negative. Similarly, if you are writing work this side, work done by the system positive, but if work is done on the system, then it will be negative. But if you are writing work this side, already this side, so means that is negative work. When it will go this side, that will become positive. Okay, so I hope that you know. So we are writing energy in equal to energy out, that's why no such sign is required here. Okay, so what is this Q2? This is 100 plus W. Okay, so now can you solve and can you make some equation out of this, guys? क्या इसको solve करके कुछ equation बना सकते हो बच्चों? Yes. चलिए, so let me solve it for you, and you also can try to solve. Okay, and you can try to make some kind of equation out of this. Okay, so अगर आप इसको solve करोगे, you will get 298.4. that is equal to W minus Q3 dot. Okay, so this is the equation we are going to get. So suppose this is equation number 2. Okay, this is equation number 2. This equation we are going to get 298.4 equal to W minus Q3 dot. Okay, so this equation we are going to get by applying this energy balance. Okay, now let us apply some kind of entropy balance also. ये वाला जो entropy balance लिख रहे थे, so let us apply that entropy balance also. Okay, so let me add here some kind of slide. Okay, so let me add it here some slide. Okay, so yes, fine. So we are having this here now. Fine. So yes. So now we can write the entropy balance also here. Entropy balance, how we can write? Rate of entropy in, that is equal to rate of entropy out, or you can write it in the capital terms also because masses are same. तो हम इसको भी कैपिटल फॉर्म में लिख देते हैं. entropy in, that is equal to entropy out. Okay, so how much entropy heat is bringing? Heat कितना entropy bring करता है बच्चों? How much entropy heat is bringing? That is Q1 dot divided by T1, that will be positive. Okay, plus Q3 dot divided by T3, that will be also plus M1 dot into what? S1. Okay, that will be S1, small s1. Okay, that is equal to how much entropy heat is taking out? That is Q2 dot divided by T2 plus M2 dot into S2. Yes or no? This is how we can write the entropy balance. Entropy in equal to entropy out. Okay, now you know all these values. ये सारा अपने को पता है. What is this Q1? This is 800 kilowatt divided by 1000. This we don't know. Q3 dot divided by T3. I think what is T3, guys? Let us check. How much is T3? T3 is 500 Kelvin. Okay, so this is 500 Kelvin. So you can write it here, 500 Kelvin plus M1 dot is what? 1 kg into S1 minus S2. S1 minus S2. Okay, या इसको मैं उधर ले जाके लिख देता हूँ. Let me write it this opposite side, because if you want to write change in entropy, so we are familiar about those formulas like S2 minus S1, change in entropy. Okay, so we are familiar with those formulas, S2 minus S1. Okay, so let me bring this heat this side. So this will be minus. Okay, यहाँ पे क्या हो जाएगा? This will be minus. Okay, so this is heat which is going out. How much heat is going out? This is 100 divided by how much is the temperature? This is 350 equal to M1 M2 both are same, which is 1, S2 minus S1. Okay, so this is the equation. This is the final equation, guys. Now how to write this S2 minus S1? Okay, so entropy change for an ideal gas, we can write it as S2 minus S1 equal to specific entropy change. So this is Cp ln T2 by T1 minus R ln P2 by P1. Okay, because the temperature and pressures are given to us, guys. आपने को क्या क्या दिया हुआ है? Temperature and pressure are given to us. If you will check it here, the entry temperature and entry pressures are given to us. Here, the entry temperature is what? 800 Kelvin. This is the entry temperature is 400 Kelvin and entry pressure is 300 Kelvin. The exit temperature is 800 Kelvin. Exit pressure is 100 kilopascal. Okay, so entry conditions, temperature, pressure, exit temperature, pressure we know. Okay, now if you'll put it whole यहाँ पे, and you know the Cp value also. Cp value is given, Cv value is given, and the difference of Cp minus Cv is R. Okay, Cp minus Cv का जो difference होता है, that is R, and if you subtract it, I think you are going to get a value close to 0.287 only, because this is very close to 1.005. This is 0.718. Okay, so you are going to get 0.287. You can check. Okay, so R we know, this we know. Okay, P2 P1 we know, T2 T1 we know, Cp we know, everything, these all things we know. So if you'll put it here, you will get Q3 dot from here. यहाँ से आपके पास Q3 आ जाएगा. Okay, now can you solve it, guys? क्या इसको solve करके can you tell me what value of Q3 you are getting? Okay, how much heat transfer is taking place from a source which is at a temperature 500 Kelvin. So this is the first question actually which they asked. ये पहला क्वेश्चन था बच्चों, ये पहला पार्ट था जो हमसे पूछा गया था. What is the heat transfer from a body at temperature 500 Kelvin? Okay, so solving this, guys, if you will solve this term, let me write it here, this term. If you will solve this term, we will get this S2 minus S1. This will come out close to 1.01121. 1.01121. Okay, so this is in kilojoule per Kelvin, kilojoule per kg Kelvin. Okay, kilojoule per kg Kelvin. Okay, because this is specific entropy. So if you will multiply it with the kg per second, इसको अगर हम kg per second से multiply करेंगे तो we will get kilowatt per Kelvin. So these all terms are representing kilowatt per Kelvin, kilowatt per Kelvin, kilowatt per Kelvin. Okay, so solving this, we are going to get Q3 in kilowatt. ओके इसको सोल्व करोगे तो आपके पास Q3 किस में आएगा, इन किलोवाट गाइस. ओके नाउ कैन यू टेल मी गाइस व्हाट वैल्यू यू आर गेटिंग, what value of Q3 you are getting? So solving this guys, we will get Q3 248.46 kilowatt, okay, which is very close to 248 kilowatt. So this value you are going to get, you can check it here whether you are getting this answer or not, 248 kilowatt. Okay, so if you will check it here guys, option number 1, the option D becomes the right answer for this. फर्स्ट क्वेश्चन के लिए ऑप्शन डी क्या हो जाएगा, राइट आंसर हो जाएगा. सो नाउ व्हाट इन्फॉर्मेशन वी गोट थ्रू दिस क्वेश्चन, द प्रोसेस इज steady, the process is reversible, but we cannot apply cyclic integration dq by dt because there is mass transfer also. So we need to apply here the entropy balance. So this is a very important concept which we learned, and other than this we learned the energy balance also. Now we know this heat transfer, ये अपने को पता है, and you know already using the energy balance we developed some equation. ये equation 2 हमने develop की है. This we got what, ये हमारा कितना है, close to 248 kilowatt. So if you will put this 248 kilowatt, we will get W also guys. अपने पास W भी आ जाएगा, work transfer. So two equations we developed, one using the entropy balance, second using the energy balance. Steady state energy balance and entropy balance using what? Using the reversible process. Entropy generation 0, del S by del T of the control volume is 0. So this is for steady, this is for reversible. For reversible entropy generation 0, for steady the change in entropy of the control volume is 0. So if you will know this, then only you will be able to solve this particular equation. Okay, so let me write it here, the work answer also in front of you, so that you will be able to match your answer guys. So the answer for work will come out 546.8 546.86 kilowatt. 546.86 kilowatt. So this will the work expression for the work we are going to get. Okay, so I think you got the basic understanding guys. So 546 option B will be the right answer. Find the rate of work produced. So we got the answer for work produced also, and as well as we got the answer for heat transfer also. Okay, so very beautiful important question guys we solved from the NPTEL assignment only. I discussed with you the basic concepts, the reversible steady state, and you know like there may be some more detail required, and you keep on, we will keep on interacting, we will solve some more NPTEL assignment questions, okay, with concepts. Okay, thank you very much. Keep learning, keep listening to YourPedia channel, and you can subscribe to YourPedia channel if you have not subscribed, and yes, you can go for purchasing this module if you are preparing for GATE or any other competitive examination. Thank you, have a nice day, and keep preparing. Good luck.